Welcome to Bit2Net Code channel. Guys, in today's session, we'll see and study BGP, that stands for Border Gateway Protocol. Okay, before we start the practical demonstration of BGP, let's understand a little bit of about the theory of BGP. BGP it stands for Border Gateway Protocol. Okay, it is one of routing protocol in popular use today that was designed as a exterior gateway protocol. This is the protocol of internet. Internet almost runs on the basis of BGP. Okay, as such, some of goals of BGP differ from those of IGP, such as OSPF or EIGRP, but some of goals remain same. Consider the similarities between BGP and various IGPs. BGPs does not advertise IPv4 prefixes like IGP. BGP needs to advertise some information so that routers can choose one of many routes for a given prefix as the currently best route. Okay, so the most important thing here I want to tell you is that BGP does not maintains a neighborship just like EIG, RP or OSPF, right? It does not do neighbor discovery, whereas it creates the static neighborship. So we have to give the neighbor command in BGP while configuring it, and then it creates a neighborship. And BGP uses a TCP, a port number 179, to create a neighborship with the neighbors. And before creating the neighborship, a three-way handshake happens with the help of TCP. And if that three-way handshake is successful, only then neighborship is created. Right. So let's have a look at more about BGP and IGP differences. For example, OSPF and EIGRP, they forms a neighbor relationship before sending routing information. Right, so this is same in BGP also. Neighbors typically discovered using multicast packets on connected subnets. In BGP, neighbors' IP address is explicitly configured and may not be on common subnet. Right. OSPF and EIGRP, they do not use TCP, whereas BGP uses TCP port number 179. These advertise prefix or length, and BGP advertises prefix or length, also called a network layer reachability information. These protocols advertise metric information. BGP advertise variety of path attributes that BGP uses instead of metric to choose a best path. Here emphasis is on fast convergence. Here emphasis is on scalability. Okay, and OSPF is a link state protocol. EIGRP is a distance vector protocol, whereas BGP is a path vector logic protocol that is quite similar to distance vector. And BGP uses autonomous number for creating or defining the neighborship boundaries. So we will look at the demonstration of a BGP shortly. For example, let's have a look here. If we have a company 1, its ASN number may be 11, and this is the another entity ISP. ASN number will be different. Then company 2 ASN number will be different, and this is ISP2 and ISP3. So all of them are ASN number different, right? So they will be connected to each other with the help of BGP. And if ASN number is different, then that is external BGP, eBGP, and if ASN number is same between the two routers, they are internal BGP neighbors, right? So let's go to GNS. and see the demonstration how do we configure internal and external BGPs. So this is the design we have in our lab environment. We have R1, R2, R3 and R4. We will be using two AS numbers. One is AS number 100, other is AS number 200. So IP address configuration is as usual, as you must have seen in our previous scenarios. We have R1, R2, R3 and R4. So and then network between R1 and R2 will be 12. Network will between R1 and R3 will be 13. 2 and 4 will be 24. 3 and 4 will be 34. Right, and IP address will be the number of routers. So let me give you the console session. So you can see that IP addresses are already configured. No protocol is running. This is R3. IP address configured and up. No protocol running. IP address configured and up, no protocol running, and IP address configured and up, no protocol running. So now we will enable BGP on R1 and R2, right? So the command will be router BGP and AS number we will keep as 100, right? Enter. Now we are in the BGP router command. So these are the commands that are available in BGP. So here first of all for configuration we will use the neighbor command, right? Neighbor specify a neighbor router. So before we enable BGP on the routers, let's do one thing. Let's run Wireshark on this interface. Okay, right now you can see that there is no protocol is running, CDP is running, and layer. This is the communication of this is the frame. Okay, no protocol is running for now. So let's go back to GNS, and now we will give the neighbor command. Neighbor, who is the neighbor of R1? We will give the neighbor of R1 as 12.0.0.2. 12.0.0.2. Okay, and then we need to give the from here we will give the this command remote AS, specify a BGP neighbor. Remote AS. Okay, what is the AS number of our neighbor? So this AS will determine if this is internal BGP or external BGP router. So we will give here AS number as 100 because R1 and R2 both are in same AS. Okay, and this we don't need. So let's hit enter. Okay, uh, now let's exit here, do right. Now let's go to R2. You can see in Wireshark till now there is no such communication because first of all TCP three-way handshake will happen before the neighborship is created. So for that TCP handshake to happen, BGP should be configured on both the routers. Uh, Router BGP 100 neighbor. We can see that we enabled as soon as we enabled router BGP command, TCP communication has started, right? So this is the three-way handshake that has happened. But since we haven't configured BGP successfully, so this TCP communication will not complete, right? So let's give this complete this BGP configure 12.0.0.1 and remote AS will be 100. Enter. Okay, so you can see that now here we will see that uh, let's have a look at this. All right, here we can see that a TCP communication has started successfully, and now open message and then keep alive messages start communicating with each other, right? So first of all, let's study this TCP message. So what is in this TCP message? TCP message will have any random source port, and destination port number will be 179 always, right? BGP uses the TCP port number 179 for creating static neighborship with another BGP router. Right, when 3D three-way handshake is successful, after that open messages are sent. Here we can see that 12001 sent TCP message, then 12002 sent. Both of them are trying to establish three-way handshake with each other, and when it is successful, let's go here. Uh, TCP1 sent a sync message, and then TCP, sorry, 12002 sent a sync ec, right? Here we can see that the 12002 replied with the SYNAC message. Okay, and after that, then 12001 again acknowledged to that SYNAC, and three-way. Now this three-way handshake is complete. When three-way handshake is successful, then open messages are sent. Okay, and they are now BGP protocol is has started running. This is the open messages sent by BGP, because TCP communication is successful. Now BGP has come into picture. So now the first message of neighborship is sent by BGP. That is the open message. Okay, let's study this now. Okay, it says my AS number is 100, and then this is open message from 12002. So this also sends the open message. It also says that my AS number is 100. Okay, so the whole time is 180 seconds. So now here we can see that a neighborship has created successfully. After that, let's do this. Let's remove rest of the messages and focus only on BGP messages. Now only after open messages neighborship is created, then only keep alive messages will be sent by both the routers to each other to make sure that the neighbor is up and running, right? Now let's go back to GNS and see show IP BGP. Show BGP neighbor. Show IP BGP. IP BGP. Here we can use neighbors command. Let's have a look at the result of this command. Now here it says BGP neighbor is 12002. That is this router. Okay, and BGP version is 4. Remote router ID is 24002. Okay, so 24002 is the ID of this router, right? So router ID is always selected as the highest IP address configured on any router. So BGP state is established, and We can see that this is a unicast IP address, and let's have a little bit more connection state is established. And these are the things that we'll be discussing in future, right? So for now, our main mm, thing that we need to have a look is this, right? Our the neighborship is established, a remote AS is 100, and this is internal link. That means it is IBGP neighbor, right? Now let's show IP. Right now there are no routes. Now, if we want to find what IP protocol is running on our routers, we can also use show IP protocols command. Okay, so this also says that right now here BGP 100 routing protocol is running, and this is running on a 12 interface, and maximum path is 1. Other routing protocols like OSPF and EIGRP have different paths. They contain 4 or more, sometimes 2, 4 or more number of paths are available. But BGP permits only one path to any network, right? So this is the default. So AD value for the BGP for external BGP is 20 and 200 for internal BGP. Okay, or for local paths. So now we have configured BGP on R1 and R2. Now we will configure BGP on R3 and R4 also. So now let's go to R3. Before that, let's configure BGP on R2 also, other interface of R2. So config T router BGP 100. So this time we are going to do this for other interface. So router BGP 100, neighbor is going to be 24004, 24.0.0.4, and remote AS will be 200, right? Enter, do right. Now let's go to R3. Now we will configure BGP on R3 also. Configure T router BGP 100, neighbor of R3 is going to be 13.0.0.1 no 13.0.0.1, and then remote AS is 100. And similarly towards this hand side it is 34, but with a different AS. So 34.0.0.4, and AS will be 200. 200 and right. Now let's go to R4. Config T. R4 is in AS200, right? So here the protocol BGP protocol AS number that we will use, it is the 200. Okay, so neighbor will be 24.0.0.2, 24.0.0.2, but it will be in a remote AS 100. So this means that this is the external BGP neighbor, right? And similarly towards this hand side it will be 34 with AS number 100. Neighbor, we got the message that neighborship up with R2, neighbor 34.0.0.2, remote AS 100. and right. Show IPBGP neighbors. Okay, here we can see that these are all the neighborship parameters. Okay, let me show you once again. BGP neighborship is up with the 24002. That means this link. Okay, and a remote router. This is the external link. Here we can see that remote AS is in 100 AS. Remote neighbor is in 100 AS, and this is the external link because AS number is different. Okay, BGP state is established here. And let's see if we have anything more worth discussion here. BGP table version 1 IPv4 unicast. IPv4 address is being used. So our TTO is 1405. We will discuss all these things in coming sessions. Okay, now let's check over here also. Uh, BGP on R3. Show IP BGP neighbor. Here neighborship is created with an R1, that is internal link. So IBGP. R1 is the IBGP neighbor of R3. Okay, and towards this hand side, other is BGP neighbor 34004. This is 34004, and this is the external neighbor because this its AS number is different. BGP version 4, right? BGP state active. Similarly, let's check on show IP BGP neighbor internal remote router, and this R2 should also have two neighborship, one with IBGP with R1 because same AS, other with R4 different AS external BGP. So this is external link neighborship with 24004, right? Show IP route. Let's see what all routes are known by BGP yet. So it has only connected routes. Show IP route. So all the routes have directly connected neighbors only. Another very helpful command that we can use is show IPBGP summary. Let's study this command also. So this gives the summarized form of all the networks. So on R4 we have two networks. One is two neighbors 24002 34002. Right, this is 24002 and this is 34002. These are the two networks. Okay, both are in AS100. And let's run same command on R3 also. So the 31 R3 neighbors are 13001 and 34004. 13001 and 34004. Let's check on R2. 12001 and 24004. 12001 and this one is 24004. and R1 has 12002 neighbor only. So that means we did not run router BGP command for this network. So let's run this also. Router BGP 100 neighbor 13.0.0.325, no, 13.0.0.3, and then our next option is remote AS. Remote AS is 100. Okay, so neighborship should come up shortly. Let's check if uh, we have configured. Yeah, now we got the message neighbor is up. Okay, so let's run a summary command again. Now R1 also has two neighbors. Okay, with AS 100, 12.0.2 and 13.0.0.3. Now guys, if I check the show IP route command on any of the routers, BGP is not advertising or not putting any of the routes in the routing table. It has only those routes that are directly connected to it. So we need to inform BGP on which networks BGP should be running, right? So that we will do by going to router BGP 100, and then we will inform BGP that with the network command. So we will give it 12.0.0, and then we will use mask command and 255.255.255.0, right, and enter. Similarly we have BGP running on 13 network. Similarly, let's run this same command on R2 also. Router BGP 100 network 12.0.0.0 mask 255.255.255.0, enter. And on R2 the other network is 24, 24, right? And on R3 we have 13 and 34. Config T router BGP 100 network 13.0.0.0 mask 255.255.255.0, and similarly the other network is 34, right? So here we will enter 34. Okay, similarly on R4 config T here BGP AS number is 200, and network command that will be 24 network and 34 network. 24.0.0.0 mask 255.255.255.0, similarly 34 network. Now let's see the result of show IP route command. Now we can see that BGP has installed these routes in the routing table, right? Now let's run on all the routers. So on R2 only to 24, 34 and 24. Okay, 13, right? Let's check on R3 also, and then on R4. R3 has 13 and 34. Let me double check. R3 has 13 and 34. Okay, and R4 also has 12 and 13. Okay, on R4 routes 12 and 13 are coming with the help of BGP. That's right. Okay, so now let's try to do ping end to end. Ping, uh, let's try to ping 24 4, right? 24.0.0.4. Okay, so we have end to end ping available. Ping 12.0.0.1, and let's try to ping 13.0.0. So now we have end-to-end connectivity, guys. This is direct connective direct neighborship. R1 has direct neighborship with R2, and R1 has direct neighborship with R3 as well. In BGP, we can also have indirect neighborship. For example, we can have a neighborship of R1 with R4 also, right? In that case, we need to have some IGP protocol running on the internal routers that will act as an intermediate path, and it will help to reach the indirect neighbor, right? We need to have either EIGRP or OSPF or running on interior or routers, so they will help to find the route of indirect neighbor, that is R4. Okay, so we'll see how we can do that also. Now there is one more very important command. Let's run that also. Show IP BGP. Right, here we can see that we have this symbol as star is the valid. Star means the valid network, and greater than symbol means best network, best path, right? So this is I means IBGP is running on a 12 network and 13 network, and similarly on 24 and 34, right? So next hop for a 12 network is 12002, right? And for 13 is 13003. Okay, and for 24, next hop is 12002. And this shows that star as well as best, right? So no, next hop is 12002 for 24 network, and for 34, it is the 24004. So for 34 it will go through 24004, and then we have for then 13003 hope. Okay, now let's run this command on other routers also. So for 12 network, the next hop is itself no value, and for 13 network, so next hop is 12001. So R2 is coming to 13 network through R1, and for uh, 24 24 network, next hop is 24004, and for 34 network it will come through 24004. For this network it will come through the R4. Let's run this on. Okay, so here we can see that uh, the best path is uh, uh, this is the best path, right? IBGP for 12 it will go through 13001. For 12 network it will go through 13001 on R3, right, through R1. And now let's check on R4 also. Show IP BGP. So for 12 network it will come through 24002, and for 13 also. So 12 or 13, it is the R2 is the next hop for R4, right? And for uh, 34 network, for this network, it is the local. So for 24, 24002. 24002. Okay, so this is also local, right? So this is the command that we can use to find the next hop of for any network, right? And these are the values for the codes that are used in this. If we see S means suppressed, D damped, H history, star relevant are this. Star means valid, and greater than symbol is best. Okay, if we have I here, I is internal route, and I is EGP origin codes, and E is EGP. If we have a question mark anywhere, that means incomplete. Incomplete is for BGP route, right? We will discuss this in future in coming sessions. Here, guys, this I means internal. This is internal path, right? And this I means here also, and other I means IGP, right? So this I is for internal path. Right, we should not because conclude confuse this I with this I. So this I means internal path, right? Guys, one very important feature of a BGP is to use the loopback feature, right? For example, right now BGP is connected to other neighbors through physical interface. But what if the physical interface goes down, right? In that case, BGP won't be able to communicate with its neighbor. But we can also configure BGP to use its loopback address as a neighbor, so that even if physical interface goes down, neighborship does not break. BGP will communicate with that router through other routes, right? So let's see how we can do that. For that, we need to have some loopback address configured on BGP on routers. So let me go to config t interior loopback one IP address. Let me give it to 1.1.1.1 255.255.255.255. Okay, and right. Let's show history, and okay, let's configure loopback interface on loopback 1 IP address 2.2.2.2 255.255.255.255. Let's configure loopbacks IPs on all the routers. Interface loopback 1 IP address 3.3.3.3 255.255.255. Similarly on R4. Now we can use this loopback IP address to be used by the BGP, right? So let's see how we can do that. Router BGP 100 neighbor. Neighbor is going to be 12.0.0 uh, 1 no 2. Okay, and remote AS 100, and here we can neighbor 12002. Yeah, here we can use a source of routing updates. Okay, update source we can keep as update source. Here we can give the IP address of our loopback interface. So loopback interface 1. right? Similarly, now if I shut down one interface, then also neighborship will stay up, right? Similarly, let me do this on 13 3. Okay, so R1 will communicate with R2 and R3 not as a physical interface but as a loopback with the loopback interface that never goes down. Okay, we'll see if physical interface goes down, then also the connectivity will be there. Show IP BGP summary. So here we can see that neighborship is up and AS is running. Now let's see if we shut down any interface. For now we can see that we are able to 12.0.0.2 we can ping, right? Now let me shut down one interface. Now let's try to ping 12.0.0.2. Let's see how it will be able to ping connect to 12.0.0.2. Okay, right now it is not able to connect to a 12.0.0.2. So for that we need to have the loopback interfaces communication to be done on other routers also, right? So let's do that right now on other routers also. Config T router BGP 100 neighbor 12.0.0.1 update source as 2.2.2.2 loopback 1. Okay, and similarly uh, on a 24 network. So let's use for 24 network also 24.4. So on an entire network we will use our loopback addresses. Okay, so this we have done on both sides. Now let's go to R3 100 neighbor 13.0.0.1 update source loopback 1. Similarly 13, and towards this side we have 34. Okay, 34 will be communicating with loopback 1. Okay, here mm, we have to neighbor 34. Okay, here we have to tell remote AS because this is a different AS. Remote AS 200. Okay, I'm sorry, 30 and not 3401. IP address is 34 and update source loopback 1. Right. So we have configured for 13 as well as for 34. 13 is 1 and 34 is 4. Okay, now that's right. Now let's go to R4 config T router BGP 200 neighbor. So his neighbors are 24 and 34, 24 2 and 34 3. 24.0.0.2 update source loopback 1 and 34 3, right? 34 3 is for R3. Something wrong with the command. 34003 R3 IP address should be 34003. Specify remote AS. We are on R4. R4 will be with 24002 34003. Let's check what's wrong here. Uh, so let's give this remote AS first and then loopback command. So now let's go back to and write show IP BGP summary and show IP route. Now we see the show IP in brief. Exclude unassigned. Okay, so now we have configured loopback IPs on all the addresses, but these loopback IPs are not advertised in BGP, right? So for them to take effect to be used as source IP addresses in BGP, let's advertise them in a BGP also, right? So for that, what will be going to router BGP 100 and network will be 1.1.1.1 to mask will be 255.255.255.255. Similarly, let's do on R2 router. OVL already network will be 2.2.2.2 255.255.255. Right now we are not using any OSPF or EIGRP, so we are advertising loopbacks in a BGP network. So that is the another idea and method we can use if we do not want to use BGP in our internal network. Okay, so this is one way to advertise loopback IPs in BGPs. So let's try this way. Network mask 255.255.255.255. Similarly on R3 network 3.3.3.3 mask 255.255.255.255, and similarly on router BGP 200 network 4.4.4.4 mask of 255.255.255.255. Show IP route. Show IP route. Okay, now we can see that all we can see that R4 is able to reach to R2 2.2 network via 24.0.0.2, right? And 4. Network via 4 is directly connected. Let's see and show IP route. So now all the loopback IPs are advertised in this. Now let's try to do end-to-end ping 1.1.1. Okay, let's try to do ping from here 1.1.1. One does not seem to be successful. Show IP 1.1. Okay, what about N2? Show IP route. Network 1.1.1. This command seems to be okay, and here also router BGP. This also looking correct. 3.3 mask 255, and in here also router BGP 100 4.4. Oh, okay. Let's try once again. Not working. Let's try from here. From here it is working. Okay. Let's see what is the problem. Ping 4.4.4.4. So it is not able to reach external BGP, right? Whereas 1.1.1.1 ping 1.1.1.1. Okay, R2 is not able to reach 1.1.1. So R2 does not know about 1.1.1 network. And what about this doesn't know about 2.2.2. Okay, so let's configure router BGP 100 neighbor 2.2.2.2 remote AS 100 and neighbor 3.3.3.3 remote AS 100. Let's do it this way. Okay, router BGP 100 neighbor 1.1.1.1 remote AS 100, right? Similarly, remote AS 4.4.4.4 will be remote AS 200. Okay, and on R3 router BGP 100 and neighbor will be 1.1.1.1 remote AS will be 100 and 4.4.4.4 will be remote AS 200. Okay, now let's go to router BGP 200 neighbor will be 3.3.3.3 remote AS will be 100 and similarly neighbor is 2.2 show IP BGP neighbors. Now let's try to ping show IP BGP summary. Okay, now we can see that neighborship is with both loopbacks and physical interfaces. So now let's try to ping 2.2.2.2. Okay, no problem. Ping 1.1.1.1 R3 and ping 1.1.1.1. Okay, R3 is able to communicate with R1. R2 is not able to communicate with R1, right? We'll try to find out, we'll troubleshoot what could be the problem. Ping. Let's see with which loopback IDs R4 is able to communicate. First check with 2.2.2.2, 2.2 it is working, 3.3.3.3. With 3 it is not working. Okay, so that means we have done any mistake in configuring neighborship of R4 with 3.3.3. So show IP route. 2 is coming in the routing table, 3 is not coming. That's why with 3 the ping is not working. Okay, so let's show IP BGP. So 3 is not in the neighbors list. Show IP BGP neighbors. Okay, here it is saying BGP neighbor 3 remote AS 100 external link, right? So guys, we have a lot of tools available in BGP to solve this kind of problem also. Let's try to do this by using indirect neighborship between R1 and R4, right? So what we can do, we can go to config T router BGP 100 neighbor, we can configure as uh, 4.4.4 4.4.4.4. Here we can use a remote AS 200 neighbor 4.4.4 remote AS 200, right? Enter, and 4.4.4.4 EBGP multi-hop. So here we have to tell that, because by default BGP hop count is 1, TTL is 1. Okay, beyond 1 it will discard the packet. So we have to tell BGP how far is this neighbor from R1. So here we can give 1, 1, 2. So here it is 2 hops away. So R4 is 2 hops away. So here we will have to give command as a neighbor 4.4.4 is 2 hops away. Okay, so similarly same command we have to give here, router BGP 200 and neighbor 1.1.1.1 remote AS 100 and neighbor 1.1.1 EBGP multi-hop 2, right? So we have created indirect neighborship between R1 and R2. Now let's see if it can reach R1 from anywhere, and show IP BGP. Okay, so here what we can do, we don't have any route. We can configure these border routers as to advertise themselves as next hop IPs, right? So what we are going to do, let's go on R2 router BGP 100. Here we can configure R2 to advertise itself and next hop for other networks. Let's do how we can do that. So here we will configure R2 to advertise itself as the next hop for 12 network and for 24 network, right? So neighbor for 12.0.0.0, sorry, 12.0.0.1, as here we can give the command as next hop self, right? So configure advertise itself as next hop for 12 network and for 24 4 network also. Neighbor 24.0.0.4 next hop self. Okay, similarly do this on R3 also. Router BGP 100 neighbor 13.0.0.1 next host self. Okay, and let's do this for this also 34 network also. Neighbor 34.0.0.4 next host self. Show IP route and let's do show IP route and show IP route. Okay, now R2 is we'll do show IP BGP neighbors. So BGP neighbor is 1, remote AS 100. Okay, BGP neighbor is 4, remote AS 200. BGP neighbor is 12, remote AS 100, and BGP neighbor is 24004, remote AS 200. So now even if physical interfaces go down, we will still have a neighborship with the routers through the loopback IPs, right? Show IP BGP neighbors. Okay, we have a neighborship up with loopback IPs. So we have a neighborship with loopback IPs for remote AS and 30 physical interface, remote AS local 100. Okay, BGP neighborship 34, remote AS 200 external, right? Guys, one method of keeping loopback IPs in contact with each other is to configure OSPF on IGP network. So let's try that also. Router OSPF 1 and network 0.0.0.0, right? Let's do this on area 0 and config T router OSPF 2 network 0.0.0.0.0 area 0, and let's do this on config T router OSPF 3 network 0.0.0.0.0 area 0. Okay, so consider this as external, so we don't need to run OSPF on R2. So let's try to show IP OSPF neighbor. We have R3 neighborship with the R1 and show IP OSPF neighbor with on 2's neighborship with R1 is also updated and show IP OSPF neighbor. So ASPF is with 2 and 3 also. Now we should have end-to-end connectivity paying uh, 2.2.2.2. Okay, we can ping each other 3.3.3.3. Okay, and ping 4.4.4.4. Okay, so we have end-to-end connectivity. We haven't run OSPF on 4.4.4, but still connectivity is there through with the help of BGP, right? Show IP route. We can see that BGP is providing us the 4 route and for internal routing we are using OSPF, right? So if we go on R4 show IP route, so these routes are coming with the help of BGP. 1 and 2 are coming with the help of BGP, and this 12 and 13 also with is coming with the help of BGP, because OSPF is not running on these networks, right? So these networks are advertising with the help of BGP, and this internal network is advertising routes with the help of OSPF. So this way we can take help of BGP to advertise routes on the internet. In case we don't want to run advertise loopbacks IP on internet, we can give the two dot loopback IPs only on OSPF, and we can exclude them on BGP network, right? For now we have configured BGP to advertise loopbacks on internet, but we can exclude them from BGP command using network command or neighbor command, and we can only use OSPF to keep communication with loopback IPs, right? This way we'll have connectivity with the help of BGP as well as IGPs for IGPs for internal network. So guys, this was the session about BGPs. Please let me know in the comment section if you like this video on BGP basics, right? Thank you for watching this video.